This is Lab 1 for Ben Skalka. Starting with the introduction and purpose, this lab involves observing charged pieces of tape and the relations with each other, along with some objects. Additionally, the purpose of this lab was to determine the sign and magnitude of the excess charges on the portion of tape. Going on to the fundamental equations. Well, the equations we used in this lab are Newton's second law and Coulomb's law. I assumed that the tapes are point charges for the calculation and that they had the same sign and magnitude for their charges. The experimental model. For this experiment, created two charged tapes, observed the tapes with their interactions with different other charged things. We determined the sign of the charge, then we held one tape above the other and observed the distance where the top tape was motionless. After this, we were able to calculate the desired information. So these were the observations we had between the tapes and other objects. Results. Well, in this experiment, the system was tape 2 and the surroundings were tape 1. So given this, we calculated that the charge of tape B was 4.36 times 10 to the negative ninth coulombs, and it had an electron deficiency of 2.52 times 10 to the 10th. This is the computational model, the coding for that, and this is the coding model for the line. Moving on to the Y. Well, why were the two Q values different for the two different models? Well, it's because the point charge focuses all the charge onto a single point and only considers a single R vector from the observation to the charge. But the line changes because it evenly distributes the charge along a line, leading to more vectors, and some of them canceling out, and just in general different values. The line charge estimate is more likely to be close to the real value because it's more of a real-life assumption, because it's not a single point, it's an actual object with area. What if? Well, if the electrons were positive and the protons were negative, we can see what would change and how the observations would change. Well, in this case, we shouldn't have seen a difference in the macro interactions. However, the direction of the electric field would be flipped. So that's the change. And lastly, the error. Well, the tapes were already charged when they came out of the packaging, and the mass of tapes was just based on the lab instructions, so it could be different for the ones we used. Additionally, the floating distance was difficult to measure due to handshaking and general human error. And the charges on the tapes may have changed and accumulated as the experiment was performed, so that could have altered the results as the charges were changing as we were making our observations.